Hello, and welcome to Exploring Axon, a podcast where we discuss Axon and its ecosystem. I am your host and Axonic developer advocate, Sarah Torrey. In this fourth episode, Steven van Beelen and I will be talking about command, event, and query handling. I hope you enjoyed this episode, and let's have a listen. Hi, Steven. How are you today?
Hey, Sarah. Yes, I'm doing great. Thanks for asking. I hope the same applies to you.
Absolutely. Thank you so much again for joining me today. We talked a few weeks ago about the structural concepts of DDD and CQRS and everything. I'd like to delve a little bit deeper into topics of event command and query handling today,
Okay.
if all good. But just in case, can we sort of do a quick recap of what CQRS is, please?
Yeah. I think that actually makes sense, right? Because some people might not have catched that previous episode.
Absolutely.
So, CQRS is an abbreviation standing for Command Query Responsibility Segregation, which is a nice mouthful. Essentially, it means that instead of having a single big domain model for your entire application, you
Right.
segregated it in two distinct types of models, one being your command model and the other one being your query model. And it's the command model dealing with operations and reacting to that, and it's the query model, which is just providing answers. It's there for being queried. That would be the short summary, I'd say.
Little short, sweet summary. I love
Yes.
it. Awesome. Thank you. So let's go a little bit deeper into that. Let's talk about command model. What is a command model and why do we need it and where do we use it?
So the command model is really there to, as I shortly said, it's the thing dealing with handling operations. So it receives and it deals with those actions and it reacts to those. So this makes it that this is its sole purpose. Handling an operation and deciding whether that operation can be performed at that point in time, given the state of that model. So that we really consolidate all that logic of, essentially, if you put it very shortly, performing an update, and put that all into a single model's job and make it its job. That would be it.
Yeah. And so just so that we're all clear, commands are basically the intent, right?
Exactly. Yeah, so I'm now talking about operations because from a description perspective, you would say an operation, but it's essentially, well, that's what a command is. It's saying, I want to do this, or I want to do that. It's really the intent of performing a certain operation. That's what a command really is, a command message, for example, really being a present tense thing as well, because you're saying, I want to do this. It doesn't mean it already has happened.
And I think that's really important to note, because a lot of times we see things, we talk about events and events are in past tense, but we hardly ever mention that commands are in present tense, because that makes sense. That's, that's the thing that first goes out, and then, then event becomes a past tense, which we will go into that a little bit later. So we hear a lot about command bus. Can you tell me what is a command bus? Because I always hear it. What is it?
Well, it's an actual lorry you get on, and that's where you put commands on, and they drive on the road. No, that would be
fun,
a
right?
weird idea about it. But no, the command bus. So I've now been talking about these operations which go to the command model. There are certain ways of getting such an operation, such a command, to your model, and it can be sent from several distinct locations as well. So you could envision this simply as a form of a highway or a road where all the commands travel on. This essentially is what the command bus's job is. So if you want to send a command or dispatch a command, you would tell the command bus, I want to send this. You give it to the command bus, and the command bus will know where to give it to. It knows how to route that command to the exact point within your command model.
Okay. And so that then brings us into a little bit, as we're getting more detail and detail. Since we are really looking at this in terms of Axon framework also, Can you tell me a little bit about how do we use these command model, bus, everything that we just talked about in Axon framework?
Yeah.
Is there an annotation for it? How do you basically go about it and design it?
Exactly. Good, very good point. To track back, firstly to the command bus point. Essentially, if you open up Axon Framework, you can find an interface called command bus, describing the kind of operations you need to do, providing several implementations, which can either be asynchronous or distributed or what will you, all kinds of optimizations you have in there. That would be it from a dispatching end, of course. You also need to handle this command going to your command model. Now, the command model can also be several things, essentially. What it most of the times is an aggregate or several aggregates. So the thing we talked about from a domain-driven design perspective, that you have a group of associated objects which act as a single unit in regard to data changes. And that's what we want to do with a command. We want to perform a data change. It's not solely on aggregates, though. You can also have a command handler part of your command model, which does not necessarily directly go to this aggregate. There can be other components dealing with handling a command and deciding where it's okay. The exact way of getting that command to the position where you would want it to be as a developer is to annotate a function with the add command handler annotation. So you would just draft up a method in Java or Groovy or Scala or Kotlin, what will you? And you would add the annotation add command handler so that the framework knows if you configure this component saying, okay, this function over here is able to handle this specific type of command.
Right. And that's really good to know. And actually, I'm actually going to go a few steps back to the command bus, because that's one of those things that has always been a little bit vague for me. And actually had a conversation over breakfast with my husband about it. The things we talk about at our home, command bus during a meal. But anyhow, so you mentioned asynchronous.
Yeah.
Is that basically the route that we're going with the command bus in Axon framework? Or can it be a variety of different ways of dispatching?
You can take a variety of things, but we typically suggest it to be asynchronous. That would be the way to go.
And why is that?
Well, because it just frees up a lot. It means that you're not busy waiting for a result, which can take, you don't know how long it's going to take. One of the strong suits of using this command bus is that on the location where you're sending the operation, you don't essentially know who's going to handle this command. And from a dispatching end, you shouldn't. You're just interested in making this change and hoping that somebody's going to pick it up. Like you're dropping it in a big bucket and that somebody's going to do it. So if you're making this synchronous, that means that when you're sending, well, you know somebody's going to send it, but you don't know when, you don't know how long it takes. That it's doable. Yes, you can do this. You could do send and essentially wait for the result.
But I'm assuming that would be a lot slower in the process, right?
Yes.
You can have to wait if there's a backlog, what have you.
Exactly. It's just a lot more efficient to make things asynchronous. It does somewhat make the coding a little bit more complex because it's a paradigm shift to some extent. But well, nowadays there are a lot of information out there to help out with that stuff, I think. So.
Yeah, definitely. Awesome. Well, thank you. That was very much clarifying. So that's great. Now going back a little bit. To command handler and how we annotate it and everything. Can you give me some examples? I mean, of course, we can't do a live coding session right now in a podcast, but can you sort of give me some sort of coding example that would go with command handler or whatever you can think of?
Yeah, sure. Let's. So one of the bigger samples we're at least creating at Exonic right now is a hotel demo application.
Yes.
Right. I believe we do not have a dedicated video out there yet, but pretty sure it's
coming.
Come.
It's coming. Yes.
So let me try to do this a little bit in the hotel perspective.
Yeah.
Let's assume I want to book a room. That's the thing I want to do. Meaning there is, and I'm doing this through an application where you can book a room for this hotel.
Sure.
Essentially, me as a user is clicking likely a button in a UI saying, I want to book this room, which would then, if you would be using Axon in this way, going from a CQRS and DDD perspective, that would mean I would be dispatching a command saying, book a room, command.
Right.
So, okay, that's what the UI portion does. It sends a book room command, and this needs to go into a certain command handler. This is what the command bus does, right? So the command bus receives this command and knows where to give this command to. Now, this book room command needs to go to somebody who's in charge of deciding if that operation can be performed at that point in time. And there might be a lot of types of different validations out there, what you need to do or make this decision. This is very domain specific. I'm going to keep it simple that the only validation we need is that we check if there are sufficient rooms in the hotel. So let's assume we have a hotel with 10 rooms in it, and somebody gives me the command, book room command. And then I check, okay, do I still have an available room for what he's interested in? Yes, I do. Okay. And then you've made the decision, and that's how you react on it. So from a more in code, you would just have, I'd argue, a class, likely called hotel in this case. Whether that's the exact implementation very much depends on the domain, right? So please don't pin me down on this.
No,
this hotel class would then have a function called, which is a command handler. So it's annotated with @command handler, and it would receive the book room command, this exact message, to be able to deal with that and then validate whether it can be performed at that point in time.
Yeah, that makes sense. Absolutely. So then from that point, what happens next? What do we, do we know that we do validation as you just mentioned? And what is the result of that validation? A little bit more into.
Yeah, that's definitely a good point. So this validation, this is really your business logic, essentially. This is where your domain logic resides in the command handlers up here. You make a decision to book a room, meaning that you essentially want to change the fact that a room has been booked. So you need to change that state. Now, from a pure
past tense.
Yes, we're going into past tense right now. From a pure CQRS stance, not really focusing on messages. Essentially, this would mean you could change the state of your model after you've done the validation. However, we see, or at least at Exonic, we see that there is a very strong benefit of doing this with dedicated types of messages, the past tense messages, thus the events. So what this means in the implementation, you would receive the command, validate your business logic, whether it's okay to handle this command. And if it was, or if it wasn't, depending on how you want to react on this, you publish an event stating what has happened. So assuming that the book room command was successful, we anticipate a room booked event to be published. So yes, we're publishing this event, and this allows us to essentially notify whomever is interested in the fact a room has been booked. Happy days. We have booked a room. Now we likely want to do something with this fact. You can very roughly see three major things when you're event handling. You're either changing state of a model. You're reacting on this by calling a potentially third-party service, an external service, like maybe I'm the manager, or you're the manager of this hotel, and whenever somebody has booked a room, you want to get an email. So we add a piece of code which reacts to this event and then sends an email to you. That would be an option. And the third one would be that there are always a bit more enhanced, rather difficult complex business transactions, taking several steps, taking some time, likely with deadlines in place. That would also be a place to react on an event. From an implementation perspective, this would be what you'd call a saga. But diving into a saga is I would argue that's too much for right now. So I think that would be nice.
We'll do an episode on saga.
Yes. Awesome. Okay. So we'll be covered over there. Somebody else is going to pick that up.
Coming up soon. Yeah. Cool.
Great. Yeah, that would be the three things. So updating a model, calling an external service, and dealing with your complex transactions.
Yeah, perfect. And then, so then talking a little bit more into depth with Axon Framework's annotation. Can you walk me through that a little bit, sort of like what we did with the command?
Okay, yeah, sure. So we're sending this event, right?
Right.
This means we need a way, a place where we can put this event on so that
Event
somebody knows
bus.
where to give it to us, right?
Right.
So this essentially is what you would have with an event bus. So similar to a command bus dealing with command messages, there's an event bus dealing with event messages, thus being in charge of receiving the event to publish it to whomever is interested. It's slightly different than a command bus because an event bus is really a broadcast thing. Because while an event is something which has happened, you should regard it as history as well. And essentially in the real world, everybody is allowed to know about history as well. So it's sent to everybody. Whereas a command is really directed to somebody who's in charge.
I see.
So that's somewhat different. So there's a different routing need of this of events. Hence, why we have a dedicated event bus. Now, okay, this is it from a publishing end, so to say. There's also again the notion of handling these events. Well, you could likely already guess, as we have a command handler annotation, we also have an event handler annotation, which you can attach to a function, notifying the framework, hey, this function is capable of handling this type of event, so that you can react on to this accordingly.
Do we want to talk about the receiving end of these events at all now, or is it too big of a topic?
Yes, that would be okay. Yes.
Yeah.
So the receiving end would be these main three pillars I was talking about, either updating the model or reacting to it. I think this is a very nice moment to introduce the notion of the other model we have, because we're doing CQRS. We have a dedicated command model dealing with the operations. We also have the notion of a query model dealing with answering things for somebody who's interested in it. Essentially, what we're now doing is using the events as the means to synchronize the changes of the command model into our query models. So what such a event handler does, so a function annotated with @event_handler, one of the things it could do is update one of these query models. So it would likely be a method retrieving the model it needs to change from a repository or from a database or from a cache. However you see fit, that's the freedom you have when you're doing this segregation. So you would retrieve that model, make the change you need to do, and then you would store it again. That would essentially be what this event handler could do.
Yeah. So as you beautifully ended it in the query side of things, let's talk about query. Yeah. So let's talk about handling the queries then. So these events are published, and we want to have access to this information now.
Yeah.
So how do we handle that?
Yeah, a very good point. So we have this query model, whose task it is to just provide the information as it's needed, and typically stored in the form it is required, because that's the way your information is needed. So you draft it up like that. This model, you need to retrieve that information from it somehow. Yes, you could use this repository or database or cache directly. That's an option. But then you're essentially tying in your UI again directly with where your query model is. That's an option, but it would be a lot nicer to again use a form of a message. So let's introduce this new type of message, talking about a query message. What this would mean from an implementation perspective more so is that, similarly to having a command bus and event bus, we have another one called the query bus, because there's again a different routing need to these query messages, meaning you would draft up a query message, you would put that on the query bus, and the query bus knows who is capable of handling this query. Then you would have, similarly to the command and event handler annotation, you would again have a query handler annotation. Who would have guessed, right?
Surprise!
Surprise. You would have this @query handler annotated function in a class, in a component, who knows how to react with your repository or database or cache directly, so that you can keep the segregation of who is actually handling this message and just return it
Absolutely.
as you see fit.
So talking about queries, and you brought up database. Let's touch on that, if you don't mind, because
Mm-hmm.
we always get questions, especially when it comes to Axon framework. Do we use a NoSQL database, or do we use SQL database?
Mm-hmm.
What is the preferred option? Is there a
So,
preferred option?
well, yeah, well, with the last one, you actually said it. There not really is a preferred option, I would say.
Mm-hmm.
This is
Mm-hmm.
so much. So what this query model really it means that its goal is to provide the information as it's required.
Mm-hmm.
It's in the as is.
Yeah,
So this very much depends on the type of request you have as a
I
user.
see.
Maybe your UI needs to have, likely it needs to have a JSON format of all the
Mm-hmm.
data.
Mm-hmm.
So why not store it as JSON? Somewhere
Mm-hmm.
in likely a NoSQL one.
Yeah.
Or maybe you do have the requirement of having a regular relational database because you need to
Mm-hmm.
have these columns and you just want to pull out a single row and represent it as such. That means you have another query model which stores in a SQL database. Or you could even enhance this further because we have more fancy types of databases out there, of course.
Yeah.
Things like Elasticsearch,
Yeah.
very,
Absolutely.
very, very good at doing text-based search. So
Mm-hmm.
maybe your application has a requirement to do text-based search.
Right.
Thus, you also have a component handling events, updating
Mm-hmm.
your Elasticsearch instance, tagged with the capability to doing these queries to the Elasticsearch instance.
So that's really
That's
amazing to know. Yeah, because then it will give you a lot of freedom
exactly.
in terms of what you can do with it, and then you don't have to go and change things drastically to be able to really use this um, way that Axon framework does the CQRS, for instance, right?
Yeah,
So
yeah,
you
yeah,
can
yeah.
just be free to do whatever you like,
Yeah, exactly.
which is great.
That's definitely one of the strong suits, I would say, of doing CQRS. Because if
Mm-hmm.
you wouldn't be doing this, you would have a single model doing and handling the operations and providing the answers, meaning you need to consolidate to a given storage format. Whilst
Mm-hmm. Mm-hmm.
now we can choose whatever suits our need best, which
Exactly.
is meaning it's going to be the best for your scenario.
Mm-hmm.
Just, uh,
Mm-hmm.
just a lot more efficient.
Yeah, absolutely. There was something that I wanted to ask you, and I'm kind of skipping backwards a little bit again.
Oh, sure,
But
sure.
when we were talking about using Event Bus, and
Uh
we
huh.
were talking about sort of publishing those events, there was a notion that I wanted to ask, and I totally forgot about it. Uh, Event sourcing. So,
Ah, yes,
is
of
this
course.
also used for event sourcing?
So when you're event sourcing, well, yes, you're handling an event. That's
Mm-hmm.
definitely true.
Mm-hmm.
But it's not directly the event bus you would be using for this.
Mm-hmm.
So you should view the event bus. So going back to CQRS, we have two distinct models. Let's assume
Right.
these are two distinct portions of an application or
Mm-hmm.
segregated from one another. There's
Right.
an event bus in the middle to get the
Mm-hmm.
messages, the events from the command model to our query model, so
Right.
that the query model can be updated accordingly. Now,
Mm-hmm.
this would be a regular event handling, streaming the events essentially. You're just
Mm-hmm.
streaming them to your end and
Right.
handling as you see fit. This would be event streaming to update a
Right.
query model.
Mm-hmm.
Event sourcing, however, is sourcing a model based on the events it has published, so on its
Ah.
own events.
Mm-hmm.
So these query models, they do not publish events. So the query models are essentially not event sourced. What
Right.
is the command model, however, because it's the command model handling a command,
Right.
validating whether it's okay to perform, and publishing an
Mm-hmm.
event. So your
Mm-hmm.
command
Mm-hmm.
model also handles events, but
Right.
just to rehydrate itself. So
Ah, I
this
see.
also adds an. I'm gonna overcomplicate it. Hopefully, not gonna overcomplicate it. I'm gonna wanted to say
Go for it.
when you're doing event sourcing, you thus have the hard requirement to store
Mhm.
these events
Right.
because you want to rehydrate this model whenever you
Mm-hmm.
need it. So these
Mm-hmm.
events need to be there whenever you need to rehydrate it.
Right.
So this essentially adds the idea of not only having an event bus, but also
Mm-hmm.
having an event store.
Right.
The event store is then used to allow for event sourcing.
So this is the notion of event sourcing versus event streaming.
Yes. This definitely justifies another chat, I think, about
Absolutely.
yeah,
Yeah.
right.
Yeah. That will
Uh,
come up too.
yeah,
Yeah.
great. That's good to hear. So
Yeah. We're
good
putting
stuff.
it all in the queue. So fantastic information. I appreciate all the clarification, but just to go a little bit maybe broader, can we talk about these types of messages that you just mentioned?
Hmm.
Why do we use these types of messages? What is the
Yes.
benefit?
Yeah. What's the benefit of doing these messages? Well, um, giving a bit of history here, essentially. Um, yeah, I'm gonna put this. I'm trying to word this in a nice ordering, right? Um, Essentially, we only had commands and events at first. Queries were
Right.
an additional thing we added later on,
Mm-hmm.
and we noticed that 10 years back when Framework started,
Mm-hmm.
you would typically just be building a single monolith, just a single
Okay.
application dealing with it, and the messages were a nice way to word it, so to say,
Mm-hmm.
just to
Mm-hmm.
describe, okay, this is what we're doing, so that you can be very generic in what you're sending over. It is
Okay.
just captured in a message. Okay. Now,
Mm-hmm.
what we noticed is that when you're already based on a messaging format, is that you can very easily distribute your application. So
Mm-hmm.
whenever you need to scale out, whenever you need to have several instances for fault tolerance reasons, or because you just have a lot of operations going through, because maybe you're a stock exchange application, you're handling thousands and thousands of commands a second, um,
Right.
using these messages was very helpful. We could
Mm-hmm.
just segregate those components as we saw fit and just
Yeah.
scale them out as we saw fit.
Mm-hmm.
Hence why we also did this for queries, by the way, because
Yeah.
if you don't have query messages, then you lose this benefit when it comes to the query model kind of thing. Now,
Yeah.
um, additionally, having the freedom to separate these components out for
Mm-hmm.
scaling needs, for fault tolerance needs, there
Mm-hmm.
can be several reasons why you want to do this.
Mm-hmm.
Some of them are a bit more functional, others
Mm-hmm.
are more non-functional related. What I mean with this is, let's assume you and I are in a given development team, as we actually are, I believe.
You
But
are.
let's assume we're working on this hotel demo,
Yeah.
and we're now a team of 5, but we are hiring more and more developers, so we're
Mm-hmm.
ending up with 50 developers. Now,
Okay.
if all 50 of them would be writing in the same repository, mixing and merging on the same piece of code, that would be
Spaghetti
management hell,
mess.
right? That's not very
Yes.
helpful.
Yeah.
This could also be a very decent reason to
Mm-hmm.
segregate your piece of code into dedicated services. So
Yeah.
moving a little bit into the idea of doing microservices as well.
Mm-hmm. Mm-hmm.
Um, so using these messages and having the fact that when you're sending a message, you do not know who's going to handle it. And when you're
Mm-hmm.
handling it, you do not know who has sent it,
Yeah.
makes it so that they can be as far apart as you need.
Yeah.
There's a term for this when it comes to networking, and
Oh
that's
yeah. I'm waiting
called
for that.
location transparency.
Transference. Very
So
good. Yeah.
it's a very lengthy story, but if I just say location transparency, well, that's likely not going to land. So I always try to
Yeah.
make it a
Oh, that's
story. But
perfect.
essentially, you could look up the term location transparency and what it means. But
Mm-hmm.
it's location transparency, which allows us to make cleanly, nicely segregated components, just
Mm-hmm.
using these types of messages to send the operations you want, to react on what's happening, and to provide the information somebody needs without knowing who's going to handle that
Exactly.
or whatever. And
And it
that's
doesn't really
definitely the
matter. Yeah.
no, it doesn't really, it shouldn't
Yeah.
matter from your
It should.
perspective, because if
Exactly.
it doesn't, it means you can pull them apart and you can
Mm-hmm.
go from a given good segregated monolith to having dedicated services or microservices,
Mm-hmm.
having that
Exactly.
freedom.
Which again, exactly, you spoke the word I was thinking, freedom, which
Yeah.
is really key, I think, because then it allows you to do a lot more with it. If you want to, for instance, expand your particular um, model, event, whatever you have, it
Hmm.
doesn't have to be connected to something else. And then
No,
in terms of deployment, then that would make things a little bit easier too, right?
exactly. Yeah.
Yeah. Can you touch on that a little bit too?
Yeah, sure. Yeah. From a deployment perspective, well, you could just the components which are dealing with handling commands, for example. Let's assume we have this dedicated command model component dealing with that logic. Firstly, it was just in a single monolith, so you would deploy it as such. But now we, as I pointed out, want to scale it out. So we pull out this piece of code, make it a dedicated repository, make this deployable, and we could run it once. We could run it twice. We could run it as often as we want. So we could deploy it in the number of needs as we see fit, just because
which I think is,
we're just using these messages. The pieces which are gluing everything together, those are our buses. So this is why I pointed out that a command bus can be a distributed format. Because if you have a distributed command bus, well, you can just give it a command, and the distributed command bus knows, okay, I might need to give it to myself, or it needs to go to other instances out there who are also capable of handling these commands.
Yeah, which is great.
Yeah.
And I think another thing that I was just thinking about in terms of deployment, and you mentioned having a team of developers. I think that would also help a lot if your team is working on something specific that needs to be deployed more frequently.
Yeah.
Another team doesn't need to have that sort of
Exactly.
frequency. That will help out a lot. I think it will smooth things out in terms of working on a project, but having separate teams as well to give them that kind of freedom too.
Yes.
Which I think is also very helpful in terms of project management and working and sort of higher level, if you would.
Completely agree with you there. It makes it so much more pleasant to, yes, you're together making this awesome piece of software, but you're not tied to what their team wants. Maybe their team wants to use a different programming language. Let them. That's fine. They're on their own. You can talk with them because you're just using these messages.
Yeah.
It's all going to be
and
okay.
I think that's fascinating that you mentioned too. You can use different languages. You can use different technologies. You don't have to all be sort of on the same location with everybody, which is fantastic. So yeah, we talked about a lot of really cool stuff that will give me ideas of future talks that
That's
we can
good.
sort of
Nice.
go more deeply into. I will come back to you.
Of course. Yeah, I was hoping so. I was hoping so. Thank you very much.
Any final points that you'd like to mention? Anything else that I missed?
No. Just to consolidate it again, it's these. Using these types of messages allows us to be location transparent, so that we can just segregate as the need arises.
Right.
And touching a little bit back on the event sourcing question, it is the difference between event sourcing and event streaming, essentially, right? So the query model is where you're streaming events to. Event sourcing is when you're updating or rehydrating the command model from its own events. Those would be the two gotchas I really want to emphasize here.
Yeah. And I think for me, the word to take away, which is one of my favorite words, just generally speaking, is freedom. You have freedom to do what you like, which is perfect. Awesome, Steven. Thank you so very much again for joining me and clarifying all these rather complex points, which is fantastic. I appreciate it.
Much obliged, Sarah. Was happy to be
have
part
a
of
great
it.
day. Thank you.
You too, Sarah.
Talk to you soon. Bye. I hope you really enjoyed this talk with Steven. Please join me next time as I talk about event sourcing and event streaming. Until then, have a great time and happy coding.